Hi guys, welcome back to school. Hope you've had a good weekend. We're going to be looking at atomic science again, if you haven't forgotten what we learned last week. Just letting you know there's going to be an announcement at 4 o'clock today from the government, and maybe they will then tell us when you guys will be heading back to school or not. So I'm just going to do a little recap of what we looked at last week. So firstly, what is an atom? An atom is a very, very, very small object, which is the building block of everything. All matter. Matter is anything that has any weight to it. So it can be a liquid, solid, gas, all made out of atoms. Atoms themselves are made from three smaller particles, known as electrons, protons, and neutrons. In this model, protons and the neutrons are in the middle or the nucleus of the atom. Protons are positively charged and the neutrons are neutrally charged. The electrons go around the atom, they orbit around the nucleus, and they are negatively charged. In a neutral atom, you're going to have the same amount of protons and neutrons. Here we have protons and electrons. So you've got the same amount of positively charged and negatively charged particles. We have 3 protons here and 3 electrons. So this is a neutral atom. All of the atoms are listed in the periodic table. Here we have 111 different types of atoms. You may have heard of some of them, like oxygen and hydrogen. And what do these numbers mean? So let's use fluorine as an example. Fluorine has a 9 and a 19 on it. The smallest number is the atomic number, and the biggest number is the mass number. The atomic number, or proton number, is the amount of protons in the atom, so 9. And it will also be the amount of electrons in that atom, if it's neutral. So if this is a neutral atom, it will have 9 protons and 9 electrons. The top number is the mass number, and that is equal to the amount of protons plus neutrons. So if we know we've got 9 protons, we were going to need to have 10 neutrons in order to have an atomic mass of 19, because 9 plus 10 is 19. So in fluorine, we have 9 electrons, 9 protons, and 10 neutrons. Make sure you do the exercises in the Scipad around that so you fully understand what I'm talking about. What do we have next? So the electrons go around the atom, around the nucleus, in rings. And each ring can hold a certain amount of electrons. The first ring can hold 2, the next ring can hold up to 8, and the third ring can hold up to 8. So when we're working out where these electrons go in an atom, we start filling up the shells on the innermost first, and when that's full, then we start filling up the next shells. So for example, here's helium on the left. It's only got 2 electrons, so those 2 are going to go in the first shell. We know it's got 2 electrons because it's got an atomic number of 2. Carbon's got 6 electrons. The first 2 go into the first shell. Then once that's full, the next 4 go into the next shell. And here's another one, sulfur. It's got 16 electrons. First 2 in the first shell. The next shell can hold 8, so we put 8 in there. And now we've got 6 left over, so they're just going to go into the next shell. Now, atoms can lose or gain electrons to get a full shell. Helium here, he has 2 in his outer shell, already full, doesn't need to gain any. Sulfur here, however, has 6 in its outer shell. Because it's got 6 in its outer shell, that means it needs to gain 2 more to get a full outer shell. Getting a full outer shell makes it stable, so this sulfur wants to gain 2 electrons. If it gains 2 electrons, that means it's going to now have 18 electrons and only 16 protons. So that means sulfur will have 2 more electrons than protons. Here it is here. It gains as 2 electrons. So now we say that sulfur is an ion because it has a charge, because 2 more electrons than protons. And we put a charge next to it, it's 2 minus here, which means it's got a charge of -2. And the reason why it's -2 is because it's got 2 more negative electrons than positive protons. Alright, so what we're going to look at today is starting off with naming ions. So an ion, when it gains or loses electrons, if it is a positive ion, which means it has lost electrons, it just has the same, it stays the same name. So a copper atom, when it loses electrons, is now called a copper ion. If it's a negative ion, then we actually change the name of the element and we put an "ide" on the end. So oxygen is a negative ion because it needs to gain 2 electrons to form an atom. So oxygen, when it gains 2 electrons, it becomes an oxide ion. So oxygen turns into oxide. Sulfur gains electrons and becomes sulfide. Chlorine, chloride. Iodine, iodide. Let's have a look at a few of them. So it's these ones on the right. Fluorine becomes fluoride, chlorine, chloride, bromine, bromide, iodine, iodide, sulfur, sulfide, oxygen, oxide, so on. So positive ions keep their names, negative ions become "ide." At the back of your periodic table, so at the back of your Scipad and your periodic table, you'll have this thing. It's called a table of ions. And this shows you what each element, what ion it forms. So hydrogen, see we've got a +1 here. +1 means they have lost 1 negative electron, so they're now positively charged. So hydrogen, sodium, lithium, potassium, they only have 1 electron in their outer shell and they want to lose it. And when they lose it, they have 1 more proton and electron, so they have a charge of +1. This one down here is a little bit different. We're not going to talk about that one because it's made from 2 different types of atoms, nitrogen and hydrogen. These ones in +2, they all have 2 electrons in their outer shell. If they lose those 2 electrons, they're going to have a full shell. So they all want to lose 2 electrons, and when they become an ion, they're going to have 2 more protons and electrons. So they will have a charge of +2. Aluminium ion, they're going to lose 3 electrons. If we move over here to the negative ions, we have fluoride, chloride, bromide, and iodide. All of these atoms have 7 electrons in their outer shell. They want to gain 1 more electron to get a full outer shell. So when they gain that 1 electron, they become they get a charge of -1. And these are all, they've all got endings with "ide": fluoride, chloride, bromide, iodide. Oxide and sulfide, they have 6 electrons in the outer shell. They want to gain 2 to become stable. When they gain 2 electrons, they get a charge of 2-. They're going to change the name to sulfide and oxide. An ionic compound is something formed by 2 different ions, a positive ion and a negative ion. An ionic compound can be formed when 1 atom donates electrons to another atom. So here we've got sodium. Sodium wants to lose one electron. Chlorine wants to gain one electron. If we get sodium and react it with chlorine, we can form an ionic reaction. Just before we look at that, we're going to look at the differences between elements, compounds, and mixtures, because this is easy to mix up. So the first one, an element. An element is a substance that is made from just one type of atom from the periodic table. Here's the periodic table here. So anything like nitrogen, oxygen, hydrogen, pure hydrogen, pure nitrogen, these are all elements. Silver, gold, these are elements. Next we have a compound. A compound is made from one or more atoms. Sorry, I'm going to change that now. Good change. One or more atoms which are chemically bonded together. So better. A compound is a substance made from one or more atoms chemically bonded together. For example, water or carbon dioxide. Water has hydrogen atoms, that's the H's, and oxygen atoms bonded together, so it's a compound. Carbon dioxide has carbon and oxygen atoms bonded together, so it's also a compound. A mixture is something that isn't a compound or an element. It's going to be made from a mixture of different elements or compounds mixed together, but not reacted together. So if I get hydrogen gas and oxygen gas, and I put them together in the same room, that is a mixture of hydrogen gas and oxygen gas. That isn't water. If I get my hydrogen gas and my oxygen gas and I react them together to form water, which is very different to both hydrogen and oxygen, then water would be a compound, because water, the hydrogen and oxygen are chemically bonded together. So here's an example. We'll have a look at the video. Hopefully the sound works. So this is what we have here is sulfur. What we have here is sulfur and iron mixed together. Sulfur and iron are both elements, but both on the periodic table. So I'll go back and we'll have a look at them better. Sulfur is the one on the yellow one on top. Iron is that grey one down the bottom. And they're both elements, and when you mix them together, you now have a mixture. It's a mixture because they're mixed but not chemically bonded together. In order to form a compound chemically bonded together, you're going to have to heat that up somehow until the reaction starts. It will happen soon. We can do this at school. You guys just have to remind me to do it. And this video works really well, but you're missing out on the horrible smell that the reaction makes. So if you want to see that, remind me when we get back to school. You may not be able to hear me from all that sound. Just worked out how to turn it off. So here they are reacting together, the iron and the sulfur, and they are forming a new compound. And yeah, it's that kind of black gross thing they've made there. That's the new compound they've made. So In that reaction, sulfur and iron are both elements. They can be found on the periodic table. If they are mixed together, they form a mixture of sulfur and iron. When heat is applied to it, they're going to chemically react and form a compound called iron sulfide. So when you write out these names for compounds, always do the positive ion first, ion, and then the negative one, the one that finishes in "ide" afterwards. So iron sulfide, to get iron and sulfur mixed together. All right, so that's all we're going to leave it at today. I'm going to give you some work to do. Sorry. So I'm going to give you some work to do here. Just give me one moment to get it up. Sorry. All right, so today, where are we? All right, so, oh no, we haven't finished yet, sorry. All right, the last thing we're going to be looking at is these things called chemical equations, and this shows what's happening in a reaction. So on the left of the chemical equation, that's this side here, iron and sulfur, we have the reactants. These are the things we have that react together. And on the right, we have the products, iron sulfide. We have just one product here, it's called iron sulfide. The arrow shows before and after the reaction, so before we put the heat in and after we put the heat in. And the plus just shows these separate things. So this is a word equation, nice and easy with words. And later on, but not yet, you're going to do a chemical equation using chemical symbols. But this is a little bit more complicated, so don't worry about that yet. So a word equation is really simple. You're going to get something like this, a description. Hydrogen reacts with oxygen to form water. To write the word equation, we change the stuff like with to a plus. So it's going to be hydrogen plus oxygen forms water. We draw an arrow to show form. So hydrogen plus oxygen, arrow, water. Kind of easy. Here's another example. Cobalt reacts with hydrochloric acid to form hydrogen and cobalt chloride. Cobalt plus hydrochloric acid form, you're going to draw an arrow, hydrogen and cobalt chloride. So we have a few questions in the Scipad about those, and it's basically just reading the sentence and changing the words like with or and to a plus, and form or reacts to an arrow. So the work that I would like you to do today is pages 16, 17, 18 and 19. For 16 and 17, it's just these word equations. So let's have a look at J at the top there. Magnesium burns in, Magnesium burns in oxygen to produce magnesium oxide. Magnesium, do a plus, oxygen, then an arrow to make magnesium chloride. Some of them are a little bit harder. This one here, zinc bromide is formed when zinc is placed into bromine gas. The product here is the zinc bromide, even though they give it to you first. So the answer to this one would be zinc plus bromine gas, arrow, zinc bromide. And for this mixtures and compounds one, Um, down here they ask, describe if it's an element or a compound. An element is just going to have one type of atom. Here's the answers. Hydrogen, sulfur, silver. While the elements are going to have two different types. Sorry, while the compounds have two different types of atoms, like your NaCl, A and C and stuff. Anyway, I'm going to leave those to you, and there will be some work set on education. Perfect. That's 20 minutes. That's all. I'll give you another lesson, another video tomorrow, and an update on what we're going to be doing at school. So for now, see you later.